Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Calculate the standard change in enthalpy for the combustion of carbon. Use standard enthalpies of formation to calculate the standard change in enthalpy for combustion of carbon. We have the balanced chemical reaction represented over here. Along with that, we have standard enthalpy of formation for each of the reactant and the product as shown. Continuing, the standard enthalpy change of the reaction is given by the following expression. Substituting in the values, we have standard change as negative 393.5 kilojoules. Converting 655 kilowatt hour into joule using the conversion factor, we have conversion is 2.36 into 10 raised to power 9 joules. Now, calculating the mass of carbon necessary to supply the required quantity of heat emitted. The reaction between carbon and oxygen is represented along with their enthalpy. The heat produced from the reaction is negative 2.36 into 10 raised to power 9 joules. Calculating the number of moles of carbon necessary, which can be determined as 12.01 grams per mole. Further, calculate the mass of carbon burnt using the calculated mole and molar mass from moles from the formula as mole equals weight divided by molar mass. Rearranging this formula and substituting in the values, we have mass of carbon as 7.2 into 10 raised to power 4 grams of carbon. The coal contained 3.2% sulfur by mass, so the percentage of carbon will be 100 minus the percentage of sulfur, that is 96.8%. Now, calculating the mass of sulfur present in a coal, which turns out to be 2380.17 grams of sulfur. Now, we need to calculate the moles of sulfur reacted in each reaction as shown. The moles of sulfur turn out to be 74.22 moles. Therefore, the mass of H2SO4 produces 7.3 into 10 raised to power 3 grams.